Okay, so we've gone through the random babies experiment by doing a little simulation by hand. And we've got the results of that. And what I'd like to do in the second part of this activity is to do some more simulation, but to do some computer simulation. And the beauty of computer simulation is it allows us to do a whole lot of trials very rapidly. Okay, so let's kind of remember where we were. So we were working on that random babies activity, and we did 25 trials, or I did 25 trials, and we got some approximate probabilities, right? So based on our trials, we had 11 out of our 25 trials had no matches, 7 had 1 match, and 7 had 2 matches. So these were our empirical probabilities by hand. Okay, and noting again the fairly small number of trials we did. Okay, what I want to do is I want to do the same thing. I want to do some empirical probabilities by computer. And I want to do a lot of trials. I'm going to do 1,000. You can easily do 10,000, but I think 1,000 will be sufficient for us. Okay. So to do that, I'm going to use our online applets that are available from our authors. Okay. So if I'm on the home page for our course, we've got a link there. Let's see, where is it? Course files and links. There it is, the Rossman Chance applet web page. I'm going to click on that, open the web page. There we go. And then we're looking for the random babies applet. Oh, there it is over here under probability. I'll click on that. There we go. Okay. So we've got our hospital. We've got our families here, and we're doing 4 babies. You can do more if you want, but we're doing the 4 baby situation. Let's run a trial. Okay, so I'm just going to click randomize. All right, here's the stork. Okay, and then there go the babies. All right, not sure if you saw that. Okay, but in that particular trial we had 2 matches. The babies are color coded. Let's do it again. Stork comes, babies, and that time I saw 1 match. Yep. Okay, the last one, color-coded. Do it again. Stork, match, match, and then no match. So I think we got 2 matches here. Okay, and let's do one more. Stork comes, babies, I see a match, 2 matches, I see 2 matches. Okay, good, those 2. All right, so we've done 4 trials so far. And let's see, what I'm going to do is I'm going to change our trials. I want to get 1,000 trials altogether, so I'm going to do 996 more. I do not want to animate those, right? It'll take forever to see that stork. You guys get the idea of that. Okay, I'm just going to let the computer run here. All right, and there it goes, doing our 1,000 trials. Here we go. So cumulative results, if we look, okay, up here in the top, it says we have 1,000 trials. Okay, 368 times we got no matches, 340 times we got 1 match, 245 times we got 2 matches, we never got 3 matches, and 47 times we got 4 matches. Why does it make sense that we never got 3 matches, exactly 3 matches? Does that make sense? Right, so if you ever had 3 matches among the babies, you had to have that 4th one match as well. Okay, so let's go over and just record our data on our sheet. Okay, in our frequency table. Okay, so 368 times we got no matches. 340 times we got 1 match. 245 times we got 2 matches. We never got 3 matches. theoretically impossible. And we actually did get perfection. We had all the parents got the babies back 47 times. All right. Okay, and then we can calculate our proportions, right? And because we did 1,000 trials, that makes life easy. So 368 over 1,000 is 0.368. 340 over 1,000 is 0.340. 0.2450 and 0.047. Okay. All right. So that I feel a lot better about than I did when I only did 25 trials. Okay. So we've got about 37% of the time we had no matches. About 34% of the time we had one match. About 25% of the time we had two matches. And just about 5% of the time we had 4 matches. Okay. All right, so those are our empirical probabilities, right? So because we simulated this so many times, we have some reasonable confidence that that's the way things would work, right? We expect that on average, about 25% of the time, we're going to get 2 matches, okay? So that's the empirical probability. Okay, so with that in mind then, we've got our questions, right, that we asked about the random babies, right? What's the probability that none of the mothers got the right baby, okay? And these are, we're going to do our answers based on computer simulation. With 1,000 trials. Okay, what's the probability that none of the mothers got the right baby? Well, 0.368. Okay. Empirical probability, right? What's the probability that exactly 1 or 2 or 3 or all the mothers got the right baby? Those are exactly the numbers in our table, right? Okay. What's the probability that at least one of the mothers got the right baby? Okay, there's a tiny little bit of calculation we have to do there, right? So when we say at least one of the mothers got the right baby, that means 1 or 2 or 3 or 4 of the mothers got the right baby. So 1 or 2 or 3 or 4, we just have to add those numbers up, right? So 340 plus 245 plus 47. Okay, my arithmetic skills aren't super fast. I get 632, I believe. Okay, so 632 over 1,000 is exactly 0.632. Okay, so empirically, the likelihood of at least one of the mothers getting the right baby, it's about 63%. Okay. What's the most likely number of correct matches of baby to mother? Well, boy, it's pretty close between 0 and 1, right? Okay. So I guess, but based on our simulation, we would say 0 matches, right? Appears most likely. Based on our numbers. Okay. All right, and the last question, on average, what's the expected number of matches? All right, that one might take a little bit of calculation, right? Well, think about it. Okay, so 368 times we got 0 matches, 340 times we got 1 match, 245 times we got 2 matches, and 47 times we got 4 matches. Okay, so if we're looking for the average number of matches, okay, if I was going to write out this data, it would be, I'd write out 368 zeros, and then I'd write out 340 ones, and then 245 twos, and so on, right? Okay. So if I want to find the average number of matches, I have to add up the observations and divide by the number of observations. right? There's 1,000 observations altogether. Now, adding all these numbers up will take a bit of work, except we know how to do this in a frequency table, right? So we could say if X is our variable representing the number of matches, then the mean is going to be, well, I have 368 zeros and 340 ones and 245 twos. I have no threes, and I have 47 fours. And then my number of observations altogether is 1,000. Okay, so that one I can't do in my head very quickly. So I'm just going to do this on my calculator. So I have okay, so I get 1,018 over 1,000, which is 1.018. Okay, so on average, I can expect right around one match per trial, right? And by the way, if I switch back to my picture, okay, all this information is given to us here, right? Okay, those are our frequencies, our empirical probabilities, and our average number of matches. Okay, down here, by the way, we can also see here's a frequency bar graph representing the number of matches and our counts. Okay, all right. In the next activity, we're going to revisit the problem one more time, but from the side of theoretical probabilities.